Hello everyone, welcome to the next video. In the previous video, we have designed the six simulation of six pulse inverter. In the simulation of the six pulse inverter, first we have designed the power circuit. After the power circuit, we converted the grid voltage and inverter current into DQ0 component, that is ABC to D DQ0 component. Then we have designed a controller to control the current ID and IQ. So this controller is designed. After this controller, we generate the PWM output from that. So this is a PWM generation which we are getting here. Now we have to add the measurements block into this. So for the measurement, we need active and reactive power also. So first we'll calculate the active power and reactive power. So take the block of from. So we want to implement this block which I have pasted here. So this is what my VD. Okay, take it from block VD. Then I need a block of ID. Okay, then same I will copy here. Then I need IQ. Okay, and then need VQ. So now I want to calculate the active power first. So to calculate the active power, so let me bring this block near, so it's very easy then. Hmm. Okay, now take the block of product VD into ID. We want the VD into ID, so we need a product block. Okay, so to this product, we need VD into ID. So connect this VD into ID. Then here I need VQ into IQ. If you add these two together, okay, if you add these two together, so that is VD ID plus VQ IQ is give you the reactive power. Then you can click on go to block. You connect here, and this go to block is nothing but your power P. So give this name as global. Okay, make this tag as a global P. Then now what we need, we want to calculate the reactive power. So I will take this two block again. You can give the input separately or you can connect it from here. So here I need the VQ and here I need the ID. VQ into ID. Okay, VQ into ID. Now next is VD into IQ. VD into IQ. Now we want to add this such that VQ into ID minus second term must be minus, that is VD into IQ. So plus minus, then this will produce you this will give you the reactive power Q. So I will connect this block, copy this block and connect here. This is my reactive power Q. If you want to implement like this, you can implement like this, or what you can do, you can connect this block separately also for easiness or for good looking. Okay, so you connect this, take this control C, control V, copy and paste here, and you connect this blocks are here, but this should be VQ into ID, and this should be VD into IQ. Okay, so likewise also you can change, uh, you can do this circuit. So latter one is for reactive power calculation. So this is for reactive power calculations, and upper one is for active power calculations. So let me create an area where this is active and reactive power calculations. Now we want to observe everything into the scope. So we need to now, so click on this question mark. Here I am giving active and reactive power calculations. Now I need measurements here. So for measurements, I will double click here. I want to measure VG. Sorry. You take the block of from. Here I need to measure the VG. This is a three-phase output. Next, I want to measure the inverter voltage, inverter current, that is INV, INV. Then I want the active power as the output. Sorry. Again, take the block of from. I want the active power over here, so P, and I need Q. Okay, so this everything I need in the output block. So now this must be connected to scope. So take a scope, double click to that scope. Okay, now set this total number of axes is equal to 4. I want this layout in vertical format, that as a column vector. Click on apply. Okay, so it will create all 4 axes. Okay, now you can connect this VG here, IG here, active power P, and reactive power Q. So I can measure the VG grid voltage. So I can give this name as a grid voltage. Here I can give the name as grid current, sorry, inverter current. Here it is active power. Obviously, this active power is in terms of watt. If you want to add a unit, you can add there. Here it is reactive power, which is in VAR. Okay, now we have to run this setup. So before running, we have to do the simulation setting. I need this simulation up to 1 second. I need this simulation up to 1 second. Click on the solver information. Keep this solver as a variable step and select the 23T mod stiff trapezoidal solver. Apply. Okay. One more block is needed, that is a power GUI block. So I will add the power GUI block. Without that, it will not run. So power GUI block is copied here. Now you can run this setup to take for the measurement. So wait a minute. So we'll run this setup. Please have some pause here. Now, let us simulate this circuit. For simulation, I did one small mistake here. Whatever the active and reactive power measurement, we have applied the DQ0 transform, which is a power variant. So in a power variant format, we have to add the gain into the active and reactive power measurement, that is a 3 by 2. So I forgot to mention here. So you add this gain here. So in this gain, it is a 3 by 2. This gain must be set. So the power is multiplied with 3 by 2. Similarly, reactive power is also multiplied with the 3 by 2. So please add these two blocks here to get the measurement. Now I will run this simulation for zero point 0.3 seconds only. See what the values we have set here. We have set the value that ID current should be 200 and IQ current should be 0. So these are the reference values. That means direct axis component is must be introduced, quadrature axis component must be 0. So let us simulate this circuit and check the measurement. Okay, So if you observe here, I have given this quadrature direct axis current is a 200. So see the amplitude of the current. Inverter current is exactly 200. It is not crossing the 200. This is my grid voltage 200. Then if I click the here, so you can observe only active power component is fed in the circuit. Okay, whereas reactive component average value of this reactive component is 0. The average value of this reactive component you will get here 0. So but due to the harmonics, this is oscillating one. So as the harmonics are present, how to eliminate the harmonics, it is through the active compensation or active compensation or reactive or passive compensation we can remove this. So here we will get this inverter current. So look to the current. I will zoom this. Oh, sorry. Let me take the horizontal zooming. So if I zoom this, you observe that wherever Y phase or this yellow is at zero positions, at the same time the current is at zero position. Means voltage and current are in phase. Voltage and current are in phase. If you want to see it separately, I will add the demux block again. Demux block. Okay. To this demux block, I will take the three inputs. I will connect this block here. From this grid voltage, I will display this here and I will connect this block here. Again, I will take the three inputs from the inverter current also. Three outputs from the inverter current. Three outputs are taken from this inverter current. I want to display this inverter current of A phase and grid voltage of A phase separately. So I will add the block of mux. I want to add the two quantities together. That is first A phase voltage and A phase inverter current. I want to display it on my simulation. So I will make this layout 5. I need total 5. Okay, right. Okay, so I have added one more axis into this. So uh, let me delete this. I will add this active component here, reactive component here, and this current I will take here. Now again you run the simulation. Okay, here you can observe that voltage and current, yellow one is the voltage and blue one is the current, both are in phase with each other. So only active power component is inserted by the or injected by your inverter. So now I want the reactive power control. I don't want any active power control. So what I can do in this, I can change the value of IQ. Now this IQ I will make it 200. Okay, IQ I will make it 200 and ID I will make ID reference I will make it a 0. Okay, so now you can again simulate the same circuit. Okay, while running this same circuit, you can observe here. Now my reactive power is there, active power is a 0. And if you observe the voltage and current is almost having the 90-degree phase difference. That means only quadrature component of the current is injected by your inverter. So inverter is injecting only quadrature component, not the wherever the current is wherever the voltage is 0, the current is at maximum. Wherever the current is 0, the voltage is at maximum position. So active power component is a 0 average, but reactive power component is minus 10 into 10 raised to 4 VR. So it is injecting the reactive power. Suppose if you want to zoom this further for understanding, so you can check here. Okay, so you observe here only active and reactive power component both are quadrature to each other. So voltage and current are quadrature to each other. Now I want output such that where voltage and current both are injected, active as well as reactive component. So you change the reference. I want active current also 200 and reactive current also 200. Okay, so 200, 200. Active current is 200. Reactive current is also 200. Now we will see how this circuit will work. Okay, let me take again run this. Now here you can observe both active and reactive components are injected by your inverter. That is, active power is also present and reactive power is also present. But to see the check the magnitude of the current. Current is crossing the 200. Why it is crossing the 200? Let me tell you what is the magnitude of the current you will get. Magnitude of current is equal to under root ID square plus IQ square. So calculate the value of ID square plus IQ square, that is under the 200 square plus 200 square. That value is obviously greater than your 200. So that's why it is injecting the current greater than 200. So total current is equal to ID square under root ID square plus IQ square. So by this way you can simulate, you can adjust your current injected by the circuit. So current injected by the circuit, you have to you can make it by your own. So you can control the active power, reactive power injected by or both injected by your inverter. So this inverter can inject active component, reactive component, or both active and reactive component if the source is your battery source or any DC source is of infinite energy. Okay, with this we are at the end of this video. A simulation of 6 pulse grid connected inverter. Hope you have simulated it. Thank you. Subscribe my channel. Thank you.